All right, welcome back. Now in this tutorial, we're going to have a hands-on of RNN and then LSTM. Okay, so here we're going to predict traits, right? We're going to predict the sentiment within a particular trait. Okay, so if you go to Twitter, there are a lot of people tweeting things. So we want to see the sentiment of what they are tweeting, okay? Whether they are saying something positive or they're saying something negative, right? We want to figure that out. So I have a particular data set that we're going to use over here, which I got it from Tweet. Okay, you can also go to Twitter, use your own API, then get the data from there directly. Okay, there are a lot of tutorials out there for you to see for you to scrub your own data for that, right? I'll give you some link of how to do that as well if you want. All right, but I have the data set here, which I have loaded at the resource session, so you can download it and then you can work alongside. All right, so let's actually get started straight away over here. So as I said, we're going to do trait sentiment analysis using RNN and then LSTM. Okay, so I'll walk you through the code so that you can just run it at your end, right? Because if I want to run it right now, it's really going to take a couple of time for us to finish this video, right? And I want to make the video as short as possible so that you can rewatch it over and over again anytime that you want, right? But in your own time, you can just run it, okay? All right, so over here, I'm importing the libraries that I'm going to use, okay? The likes of pandas, numpy, regular expression, NLTK, SpaCy, string, keras, NLTK. These are things that you know already, right? So I'm just importing the normal thing, right? So here, as I said, I'm going to use this data set, which I told you earlier on, right? This is the data set that I'm going to use. Let me show you how it looks like. Okay, let me open it for you to see. So I've loaded at the research session, so you can just open it for yourself too, right? Let's see how it looks like. So this is how basically it looks like. So we have some of the traits which are labeled as 0, some are labeled as 4. Okay, if you go all the way down, you see that there's also some of them that are labeled as 4, 4, 4, 4, 4, 4, right? And then there are some that are labeled as 0, 0, 0. Okay, and then the traits are also there, right? So you can see the traits that the people are treating. Okay, for instance, this one is saying that it's upset that he can't update his Facebook by testing it. Blah 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 blah. So quite a lot of them, right? This one saying spring break in Plain City, it's snowing, right? I just pierced my ears. A lot of things that people are treating over there. Okay, a lot of things that people are treating over there. So this is what we're gonna use. It's quite a huge traits data set that we are going to use over here. You can see where this one is. If I scroll all the way, right, all the way down, it's quite huge. Okay, it's just quite huge. It's quite huge over there, right? Okay, so that's basically what we're gonna use, right? 10,101, right? 1,160. Okay, traits that we have. That's what we're going to use over here. So here I'm loading it, and I'm just showing you the first 5 and the last 5, right? Because you can see that there will be a break over here. All right, so you can see that we have 0, 0, 0, 0, 0, and then some are also labeled as 4, 4, 4, and then we have the various traits. Okay, that's how it looks like. So that's what we're gonna do. So we will start by doing some test pre-processing, right? So that is a very important step. That's why earlier on we have spent much time talking about the various test processing, pre-processing techniques like removing stopwords, special characters, lemmatization and stemming and all that. Okay, so that's what we're going to see over here. So first, what I'm doing is that I'm making sure that I convert all the traits to a string. Okay, I'm making sure that I convert everything to a string, because some of the functions that we're going to use is going to assume that all the traits are strings. So that's basically what I'm taking care of. Then I'm converting everything to a lowercase. Okay, so you can see that I have df traits, right? I'm selecting the traits column, and then I'm converting everything to a lowercase. So if you see it over here, you can see that all the traits will be converted to a lowercase, right? For instance, this one was starting with capital, right? But you can see over here it has been converted to a lowercase. Okay, so that's what I wanted to do right here. I'm just trying to show you the first I mean the first data points, this one, okay, or everything over there as well as that, just for you to compare. And then you see, so this one was saying something here which starts with capital letters, and then you can go here. There's a capital letter here, 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 capital letter here, all right, there's a capital letter here. But you can see that after that, we have been able to remove convert all the capital letters to lowercase. So you can see this one, right, converted to lowercase. You can see this one converted to lowercase, right? You can see this one converted to lowercase, right? Over here, you can see this one converted to lowercase, right? You can see this one converted to lowercase, okay, converted to lowercase. You can see this one converted to lowercase. So that's basically what we want to do, right? So that we'll be able to work, removing redundant data points and all that, right? Because we don't want words like, say, if there's a word which starts with capital letters, say oh, and then another word, the same word comes again like oh, but this time starts with small letter. We don't want our model to confuse it. That okay, they are two different things, but they are the same. Just that one was starting at the beginning of the sentence, and the other one was somewhere in the middle. That's why it's small letters. But I mean, they are all the same word. So we want to make sure that we take care of all those kind of things. All right. So now, if we check, we have these many traits. Okay. Remember, once I do that, I've here I created a new column. All right. I call it processed traits. Right, which is a new column that I'm creating. So going forward, I'm just going to continuously work on the process traits. Okay, I'm just continuously going to process it. The first processing that we have done is to convert everything to a string and then convert everything to lowercase. That's what we have done so far. So I'll continuously do a lot of pre-processing on that process traits. Okay, so we have around 101,159 traits in there, right? So the next one that I'm going to remove is the @ symbol and also the usernames. Okay, so there's a function in Keras which we refer to as trait tokenizer. Okay, so for that you can specify that strip handles equals true, which is going to strip all the handles for us. Okay, so that's basically what I'm going to use. So I'm just going to loop through all the process traits. Okay, and then each of the traits in there, I'm just going to tokenize it. Okay, and then apply that this thing that I've created over here, which is going to remove all the handles. Okay, I'm just going to apply that on it, and then finally I join them back together, right, like the way they used to be in the form of a trait sentence. Okay, that's basically what I'm doing. So I just if I pick any old text over there, I replace it with a new one that I've processed. Okay, then here I'm just printing them for you to see. So here you can see that we don't have the handles anymore. Okay, we don't have the handles anymore. You can actually verify it from the table. Okay, here was the handle. Here the Twitter handle was this one. Okay, this is the person that tweeted this, but you can see here that has been removed. Okay, if you come here, right, this is the person that, or the Twitter handle that tweeted this thing. It has been removed. So now it starts from I dived many times for the ball, right, something. So that's where it starts from. The Twitter handle has been removed. Okay, if it's not there, if there's no handle there, then there's nothing going to be done over there. Okay, but if there's a Twitter handle over there like this one, it's going to remove it. Okay, respectively. So that's basically what we have done. So let's continue to do it. Now we're also going to remove punctuations. So I'm using string.punctuation, right? Previously I've shown you different ways of removing punctuations in our during our lesson time, right? So you can also refer to them and then use them as well. Here I'm just using string here. Okay, string.punctuation to remove all punctuations. All right, so I store everything in pant to remove. That is the punctuation to remove. Okay, so when I come here, I'm using translate over here, right? So make translate. It's going to go into the text that we have, right? Remember, this is a function that I'm creating so that later on I can call that function and pass in my text. Okay, so if I call the function and I pass in my text, it's going to remove all the punctuations, right? Now there's also if you call this make trans, right, it's going to remove the punctuations, right, and then find something to replace the punctuations. But in this case, I don't want you to replace the punctuation with anything, right? So I just want to remove it, and that's it. So that's basically what I'm doing. So here, what I'm doing is that I'm calling that remove punctuation function that I've just created, okay, and then passing in each of the text, right, that I have. So I'm using lambda function here, and I'm representing this test here as any test in my trait processed. So if I pick any text over there, I apply this one on it, okay, so that will be able to remove any punctuation. So here, if you see it now, you can see that all the punctuations have been removed. Okay, all the punctuations have been removed. Even if you see the URL, right, we have HTTP : and then / / but you can see that's not the HTTP. There's no colon anymore, right? Punctuation removed. / / is also removed. You see that now trait pick is followed by what? Trait pick over there, right? And even the dot has been removed, right? And instead of .com, it's just com over there, right? And then / has been removed. So all the punctuations, you see that there was a dash, there was a comma, and so on. They are not there, okay? It has been removed. Then we're going to also remove URLs, right? So what I'm trying to do is that I'm separating these things so that when you have any use case which you require to remove any of these things, you can easily refer to this notebook and know what to do. For instance, if you want to convert your text to string, you know which cell to use, right? Here you can easily come and refer to it. If you want to convert to lowercase, you know which cell to use. If you want to remove any art and the usernames in your data set, right, you know which cell to refer to, right? If you want to remove punctuations, you know which cell to remove to. I can put all of these things in just one cell and run it at once, right? But that wouldn't help you in the learning process, right? You need to know each step by step, so that later on you can just apply all of them, and then you can easily use them. So here I'm removing URL, okay? I'm creating a function which is going to help me remove the URLs. All right, so you can see over here that here I'm using regular expressions. Then I'm indicating that if you find any HTTP, whether HTTPS or without the S, remove it, okay? Because there are some URLs that start with HTTPS, and then there are some that start with HTTP, right? If you come here, you see that this URL here was HTTP and then : / something, okay? But there are also some URLs that start with HTTPS something. So whether it's HTTP or it's HTTPS, I want you to remove them. Okay, that's basically what I'm doing. So the function name that I've given is remove URL. So I'm going to apply that to remove URL over here. So I'm going into that trait processed column, right? And then I'm going to apply this to remove URL over there, right, on each of the traits that I have over there, okay? And then I store the result over here. So that result is going to replace each of the traits that I have already over there, right? So if I show you some of them, right, you can see there's a whole sentence here without the URL. You can also see it from the table itself, okay? So for instance, this HTTP blah blah blah, blah, this was a URL, okay? So you can see that it has been removed completely, and now you start with the trait itself, right? You can just go through all of them and see. This one I'm just showing you the head, but you can actually see that it has been removed. We don't have any URL in there, because the URL is not going to help us predict the sentiment. The words are the ones that are going to help us predict the sentiments, right? We don't need the links in this and the text or the trait to predict the sentiment. Then here I'm also removing emojis, okay? So you can see this notebook is quite robust for you, right? There are a lot of things here that you're always going to need to refer to, right? I'm removing emojis over here. So I'm creating a function called remove emoji, right? And which I'm going to pass in any string that I have or any text that I have. You can call it string or text, right? And these are the emojis that I'm going to remove. So as soon as you encounter any of these emojis, you can remove it. You can just go to this link over here, and then you see the entire list of the emojis that are there. Right here I have a list of the emojis over here. So as soon as I apply this remove _ emoji on my traits, right, if it encounters any of the emojis in my trait, it's just going to remove it, okay? So here I was just testing it out. I have this string over here, or this sentence, right, game is on, and then with some 2 emojis. So I apply this function on it, remove _ emoji. Okay, so you can see that once I did that, it has removed those 2 emojis from there, right? See that they are no more there. So I'm going to apply the same thing in my data set, right, in my traits processed column, right, and then remove all the emojis, right, which I'm storing here as a result, and then I'm going to replace all the traits in my processed column with the new one that I've processed. Okay, so basically that's what I'm doing. Okay, so if there's any emojis over there, it's not gonna show. Okay, then we also have what is called emoticons. Okay, so emoticons are another way of expressing emojis. Okay, but in this case we use symbols, right? We use symbols like this to actually do that. Okay, so for instance, a happy face or smiley can be represented as this. Okay, it can be represented something like this. So I mean, I'm sure you've been seeing something like that. Okay, laughing can be represented something like this. Okay, so some people use emojis, others use emoticons to express themselves. Okay, to express their sentiments. So that's basically what I'm taking care of. So there's a long list of emoticons that I want to remove because I don't really know which one they have used. So I'm listing all of them. If you encounter any of these emoticons, remove them. Okay. So that's basically what I'm doing. So I'm creating a function here to remove the emoticons. Okay, function to remove emoticons. And then over here, any format of this, right? So you see that you, then apostrophe something, then bracket will open, and that's how it is, right? You something. Okay, that's how they express the emoticons. So that's what I'm doing over here. Okay, so once I encounter any of that such format in my in my test, I'm just gonna remove it. Okay, so if you see, for example, what I showed over here, so hello, and then the person put a smiley face over here. Okay, so once I apply this remove emoticon, which I have created for that function, right? Once I apply it on it, you see that the emoticon is removed. Okay, the emoticon is removed over here. Okay, so that's basically what I want. And then I'm going to now apply it on my data set. Remember, this is just an example that I was using. So if I apply it on each of the traits that I have in my process traits, now I can store everything in result and replace the old traits with a new one that I've processed, removing the emoticons, and that becomes my my new trait over there. Okay, so that's it. And then I'm just printing sample for you to see, right? If you see the heading over here, right, you will not see it. Here you are not seeing any emoticons, but if we had encountered, remember there's a huge trait over there, right? So you cannot go through step by step through all of them to see where it is located, right? But even if it's there, it has been removed for us, right? And then here I'm checking if there are any if there are any missing values, right? And you can see there are no missing values in there, right? And as I said, our data is actually labeled as that is our target, is labeled as 4 and there's 0, okay, over there for us. But as we saw over here, we have 4, and then you can see some labels as, if we go up, some labels as 0. Okay, so instead of 4 and 0, right, where 0 represent negative trait and then 4 represent positive trait. So I'm just going to rename the 4 to 1 so that it will be 0, 1. That makes a little more sense. Okay, so I'm going to replace 4 with 1 over here. Okay, so that I have 1 and then 0. So 1 represents positive, right, and then 0 represents negative. Okay, so positive trait and then negative trait. Right, so if the trait is negative, then it has been labeled as 0. If the trait is positive, it has been labeled as 1. So that's what we will be predicting. Okay, here you can just uncomment everything over here, right? They are just libraries, with some libraries that I'm going to use, and I didn't want to use them one by one, so I just put all of them here and then I run it. So you can just uncomment them and then run it once. Okay, all right, then I'm removing stopwords, right? Previously I've showed you Keras. In Keras we have stopwords over there which you can use. Okay, in Keras we have stopwords over there which you can use. Right here I'm explicitly defining these stopwords, right? But they are not actually necessary to do that. You can also use the Keras stopwords over there to do it. Okay, so what I'm doing is that I'm creating a function here called cleaning stopwords, and that is going to make sure that if I pick any of my tests, right, and then I split it, because I'm going to compare it, each of the tests in the trait, I'm going to compare it word by word to see if you find any of the words in the stopwords that I've defined over here, then it is going to remove it. Okay, All right, so basically that's what I am doing over here. Then I'm applying that function over here, right? You can see that I'm applying the function cleaning stopwords over here. So you can see that's the function that I created. So if I do that, any stopword in my data set is going to be removed. All right, so this is finally what we have. Okay, so remember here we're having 0 and 4, but I have renamed everything to 0 and then 1, okay, respectively. All right, and then we have removed stopwords and quite a lot of things. Now we also have stemming and then lemmatization, right? And previously we got to know that lemmatization works way better than stemming. Okay, so if you want to do stemming, if you want to test it out, I've already written the code over here for you. You just uncomment it and then you use it. Okay, but here I'm only doing lemmatization because that works very much well. Okay, and I'm using WordNet lemmatization over here, and then I'm going to lemmatize each of the data points. I'm creating a function called lemmatizer on test, okay, which I'm going to pass in each of the data points that I have, or each of the tests. Okay, then I'll lemmatize them respectively. So I'm just applying that lemmatizer on test on each of the tests that I have. Okay, and that's what you're going to have as a result over here. Okay,